we're just going to be talking about the counter and divide by circuitry in our clock. It all starts with the Schmidt trigger oscillator we're using to get 60 hertz out of a 5-volt DC signal. We have a variable resistor here so that we can tweak the frequency if we need to. That is then feeding into our first divide by 60 circuit. What this circuit does is it takes the 60 pulses per second signal and slows it down to 1 pulse per second. We have a decade counter here, and we also have a Mod 6 chip. So basically the clock pulses coming into the decade counter. It's being divided by 10 there, so we're getting 6 pulses per second. It's then going into the Mod 6 circuit, which is further dividing that by 6 to get 1 pulse per second, and is feeding our 1 second LED, which you can see is pulsing 1 time per second. We're going to take a look at the oscilloscope. And here you can see our 1 hertz clock pulse. We're actually at just slightly over it right now, but that's okay. And you can see the pulse right there. So that's our 1 second pulse. And now I'm going to turn it over to Langley to talk about the minutes and hours counters.
Alright, so what we have here is a nice little system diagram of our clock time. As Richard discussed, we have our divide by 60 for our seconds pulse. Sends out a pulse to our LED there. Then we have a divide by 60 for minutes, so that will send out 1 pulse per minute. From there, we go into a decade counter, which will give us a count 0 through 9, and that'll be our least significant minutes. And we can see from here, the fifth chip in from the right is the decade counter. So that gives us our 0 through 9. One more to the left, and we have a Mod 6, which gives us our most significant hours. It's also visible here. So that gives us our 0 minutes through 59 minutes. If our clock pulse for our most significant minutes comes from our least significant minutes, and as it reaches a 9, the clock pulse falls and sends a pulse into our most significant minutes. From there, the most significant at 59, or at 5 I should say, it changes, the clock pulse falls, sends a clock pulse into our least significant hours, which then counts 0 through 9 as we're doing a 24-hour clock, as Richard has demonstrated. So we come back to our circuit, and it would be this very last chip here. So it is a 74LS93, so that gives us a divide by 16, which we have resetting at either 24 on our clock, so it goes back to 0-100 hours, or it automatically resets itself at the 9's minute count. That is done through a series of ands and ors chips. And finally, we have our most significant hours. This counts 0 through 2, resets on the 24th hour back to 0-100 hours, and 12-hour clocks are planning to be implemented later next week.